Hi, good morning. Do you all hear me? If yes, please raise your hand in the small button. Okay, thank you so much. Thank you so much. Now, hi, I'm W.L. Lee from the Department of Building Services Engineering and also the subject seminar of this subject. This is the first lecture and also the first lecture that is online. So I do not have experience, and I guess you don't have experience either. So we try to work together to make some online lecture smooth and also not too bored, and you would enjoy it. Okay. And I would like to introduce you that there is a chat here. So if you have any questions throughout, you could just type in your questions like I'm doing. Hi, good morning. And then press read. You could use this chat function to ask me questions throughout the class, because unlike face-to-face teaching, you could raise your hand, you could ask in the class. But here is a big problem that you cannot you can raise your hand, but you cannot raise your questions in words. So you could just type questions and then press return. Okay. Any question? If no, then please raise your hand. Any question? If no, okay, thank you so much, John. Okay, thank you so much. Okay, let's move to the lecture. Okay, this is the first lecture. So I would like to, I would like to give you, thank you. I would like to give you an introduction of the subject management, the introduction of subject management. Now there is an icon on the left hand, top left corner. If you find the PowerPoint too small, you could zoom in and zoom out. Okay, you could zoom in and zoom out. Okay, the first lecture on building introduction to building ecology. I will give you a brief introduction of subject management first. Okay, the teaching program. Now, this is BSc 1572, Introduction to Building Ecology. I'm the subject seminar, W.L. Lee. And here's my office, my phone number, and also my email address. You're welcome to email me anytime you wish. And then you could also call me. And for my office, if you want face-to-face consultation, you are welcome to come to my office one-on-one. Sorry, one by one, not one-on-one. You could come to my office one-on-one so that I could give you face-to-face consultation. And because this introduction to building ecology, that is quite a broad-based subject, so we have to get experts in different areas to teach different topics. Here we have two co-lecturers, that is Dr. Hilda Zhang, her office, and also her email address, and also Dr. Philip Wang, his office, and also his email address. Okay. And the teaching arrangement, there would be 10 lectures at 9:30, but from next week we will start at 8:30. Lectures would normally be 2 hours from 8:30 to 10:30, and then be given 3 tutorials. 3 tutorials. Tutorials would be from 10:30 to 11:30. And here's I've given the room number. It's only applicable to face-to-face lectures and also teaching. At the moment, it is all online. And you'll be given one site visit, guided site visit. The date here is a bit mystic because the schedule has been rearranged. Anyway, you'll be given one guided site visit. And you're also given 2 consultation sections on a site visit report, which you are required to submit. Okay, so for site visit report, you will be given one guided site visit, and after the site visit, you have to do a site visit report, and you are given 2 consultation sections on how to write up your site visit report. And then there would be one in-class assessment, that would be in the end of the semester. Okay. Any questions? If no questions, then I'll move on. If you have questions, please raise your hand. Okay, so I move down, right? Now, intended learning outcomes of this subject. Upon completion of subjects, students will be able to consider the interconnections between buildings and the urban environment, how they are related. Buildings and the environment, how they are related. And you'll be introduced the importance of building ecology. Why we need to achieve building ecology. And then you need to know how to analyze the performance of different building designs, whether they are able to achieve building ecology objective. And if not, then you need to identify strategies to help create building ecology. So you need to identify what are the strategies available to help create building ecology. And then you need to apply those identified strategies to achieve building ecology. Okay, you have identified and then you apply strategies. After that, you need to evaluate their effectiveness. So evaluate effectiveness of different strategy. That is the intended learning outcomes of this subject. Okay. Assessment. I guess most of you are very concerned about assessment. Now, there would be one what we call student-centered seminar report and presentation. So the seminar topic will be chosen by students. The report as well as presentations would also be delivered by individual students. It is an individual report, contributes to 40% of the subject grade. That is quite a heavy rate. And then a group report, that is a building visit report. Group report, 30%. And then an in-class assessment. And in-class assessment, of course, in-class assessment that is now changed into online assessment possibly. So individual, 30%. Not yet finalized whether it would be in-class or online, right? But anyway, it is individual, 30%. Now, seminar project, that is individual, 40%. And you need to select a topic. And that topic selections would be done online at Blackboard. And topic selection would be closed on the 3rd of March in the midnight. Okay, so you need to refer to Blackboard to choose topic. And the topic selection will be closed on the 3rd of March. After you have chosen your topic, you need to prepare a PowerPoint presentation file with your voice, with sufficient content for 4-minute presentation. Okay, so you need to prepare a PowerPoint and then with your voice to present the PowerPoint. And in the PowerPoint, you may also add your own explanation and your notes because the PowerPoint is to be submitted. And in the PowerPoint presentations, all students are expected for a 4-minute PowerPoint presentation. Okay, and on seminar details, there has been an instruction posted on Blackboard, so you may refer to the instructions given in the Blackboard. Okay, any questions? Okay, thank you so much. And here's are the seminar topics, altogether 10 topics. Light pollution. Later on, you will know what is light pollution, air pollution, road traffic noise, solid waste, electricity use of photovoltaics, water use, land use, the use of recycled materials, and also greening and landscaping. Now, there are altogether 10 topics. In order to have a good spread of different topics, your class is around 40 students, so I've given 10 topics. No more than 5 students can choose the same topic. So when you conduct a topic selection on Blackboard, you have to see if there are already 5 students who have chosen the same topic. If there are 4, you could then choose the topic. But if there are already 5 students who have chosen a particular topic, you then have to choose another topic. And I would, based on first come, first serve, to decide on which topic you are responsible to work on. Okay? So bear in mind that no more than 5 students can choose the same topic. Okay? Any question? Okay, so I move on to this building visit report, group report. Now, you are given one guided building visit. So after the guided building visit, you need to conduct one self-arranged visit. Okay, self-arranged visit. And your self-arranged visit can be anywhere, but preferably be in Hong Kong, because last year there are students, they are from the mainland, and then they want to work on a special buildings in the mainland, so they chose one building in the mainland. But now I guess we cannot go anywhere other than staying in Hong Kong. So the self-arranged visits preferably be in Hong Kong. And after the 2 visits, you need to write a building visit report. As the building visit report, which contributes to 30% of the subject, it is also quite heavily weighted. And therefore, you are given consultation sections to know how to write up the site visit report, because you are all year 1 students. You may not have the experience of writing up reports. And in the report, the main requirement, that is to summarize and describes the engineering systems installed in each of the 2 buildings. So what are the engineering systems that will be introduced later? Then you need to make a very rigorous comparison on the engineering systems installed in the 2 buildings. That is the main requirement of the building visit report. Submission, that is almost end of the semester, so you don't need to worry. You may not be able to arrange visits or to see your classmates or whatever. Okay. And then in-class assessment, closed book. Bear in mind, it's closed book. And as I mentioned, right, it is in class currently the plan, but later on it may turn out to become online. I cannot say much on this. And then 2 hours assessment, that is 2 hours to cover all topics in this subject. And it would be a mix of multiple choices and short questions. Multiple choices and short questions. Okay. And then here's the teaching scheme. Okay. Now, this is the first lecture. I will give you an introduction of make it bigger. Okay, an introduction of the teaching program, which is done just now, and then also give you an introduction of building ecology that will be done online. And then you will be introduced the relationship between the building and the environment, that is on the second lecture. And the building's impact on the environment mainly includes resources use. So you'll be introduced resources use of buildings that include water, energy, land, and materials. Okay? And the impact of buildings on the environment also includes the environmental loads from buildings. And that lecture will also be conducted online. And then we have the buildings, the characteristics in order to achieve building ecology. So there are two main systems, that is the active systems to achieving ecology. The active systems, that is the building engineering systems. Building engineering systems. Later on, you will be introduced what are the building engineering systems, and you'll be introduced the design considerations of building engineering systems, that is like lighting, air conditioning, ventilation, electrical installations, plumbing, drainage, and fire service installations. That would also be conducted online. And you will be given 2 weeks recess period. 2 weeks recess period. That is mainly for self-quarantine of students from the mainland. And that period, that hasn't been, the length of that period hasn't been fixed yet. So the subsequent schedule may subject to change again. So the teaching scheme may also be changed later. Okay, but you will definitely be informed if there's any change of the teaching scheme, right? Don't worry. And after the recess period, you'll be given a guided building visit on building engineering systems, mainly that is the active systems. Details will be advised when and where to when that is the exact time for the guided building visits. And here I have graded some activities. Those are requiring your attention because that is your activity, like submission of seminar PowerPoint, completion of site visit report grouping, topic selection, etc. Those require your actions. Okay, those graded parts require your actions. And then we would have a Easter holiday break. So one day, that is week 13, there would not be lecture. And after that, you'll be introduced alternative energy sources, because building engineering systems normally consume electricity, but there are in fact other alternative energy sources like solar, photovoltaics, hydraulic, or the use of gas instead of electricity. So you'll be introduced what are the alternative energy sources available. And you will be introduced of the passive systems to achieve building ecology. The passive systems, mainly that is the building envelope, how they are designed, and are there greenery systems provided like green roof or vertical greenery, and also how the building layout, the floor plan could help achieve building ecology. You'll be introduced of the passive systems. And then, as I just mentioned, right, you have alternative energy sources. So you need to conduct energy analysis and also life cycle cost analysis to see how the different active system designs or passive system designs would affect the embodied and operating energy as well as cost. Embodied energy, that means it's the energy used for construction of a building or the production of a building feature, that is embodied energy. And all building engineering systems, they are moving installations, so they need operating energy. Therefore, with the introduction of active systems and passive systems, you'll be introduced how to conduct energy analysis as well as cost analysis for the use of different active systems and passive systems. And after that, we need to know the environmental loadings from different designs. Environmental loadings, nowadays the main concern basically is greenhouse gas emissions. So you'll be introduced of how to conduct carbon footprint analysis for the use of different active systems and passive systems. So here's the teaching scheme, and this teaching scheme has been uploaded to Blackboard. Other than teaching scheme, the seminar instructions, site visit report instructions have also been uploaded to Blackboard for your reference. And students are very concerned about assessment, so I've also posted the last year's assessment samples on Blackboard for your reference. And as this is only the second time we run this subject, so you only could make reference to last year's sample reports as well as sample in-class assessment questions, as well as the solutions. Okay. So any questions? Any questions? Now, if you have questions, you could raise your hand, or you could use the chat function to ask questions. Is it too tiring to attend online teaching, or it's okay? If you are all okay, please raise your hand. Thank you. Thank you so much. Yeah, thank you so much. Okay. In fact, I look at the trend, say that it's 29, and I remember this class 44 students. So it's in fact quite good, because normally my experience with morning lecture, students always are absent, and today seems quite encouraging. Thank you so much. Now, after the introduction of the teaching arrangement, I would like to give you a break of 5 minutes. And after 5 minutes, I will give you an introduction of what is building ecology. Okay? Thank you very much. Let's have a break of 5 minutes. I'll see you all again at 10 o'clock. Okay? Thank you. Okay, really sorry about that. Just now we have a very important visitor in my room to watch my online teaching, so I stopped for a while. Really sorry about that. Are you all here? If yes, please raise your hand. If you are all here again, please raise your hand. Oh, thank you so much. I introduce you the building ecology cycle. Now we have the environment, and the environment got natural resources. So natural resources goes into buildings, and buildings got active systems and passive systems. Okay, so active systems and passive systems, they have their operational needs. So we also need to look at the operational practices of those systems. And if these systems could achieve building ecology, we could call it building ecology engineering. And building ecology engineering systems would then contribute to the development of sustainable buildings. Here's sustainable buildings. And if buildings they are sustainable, they would have minimum environmental loadings. Environmental loadings include wastes, pollutants, and also other byproducts that would go back into the environment, and then we start another cycle. That is what we call building ecology. Okay, so in short, the definition of building ecology, that is, building ecology is the relationships and interactions between buildings and the environment. And building ecology engineering, that is a positive design goal that sets out to improve the health and vitality of buildings and to minimize negative impacts of buildings on the environment. So the key focus, that is, we have to have a positive design goal, and also we need to minimize the negative impacts of buildings on the environment. Okay, and therefore, to achieve building ecology, the first principle, that is to develop sustainable buildings so as to minimize the environmental impacts or loadings on the natural environment. Okay? Any questions? If you have questions, you're welcome to raise your hand or ask questions through the chat function. Okay, thank you. And then, what is building? Is this building like a hut that is acceptable to you? Okay, so yes or no? I give you a polling. You answer me yes or no. Okay, there are 11 or 12 students saying yes. Oh, still continue. And 8 students got no response. I guess you're neutral, right? And there are 12 students saying yes, this building is acceptable, and 10 students saying it's not acceptable. It is out of my expectations. I thought majority of the students would say not acceptable. But anyway, this is a building, but it may not be fully satisfy our needs. So for modern buildings, what else do we need? What else do we need? We need a building that is safe. Therefore, we need to provide buildings with fire protection and detection system. Fire protection and detection systems. We need the building that is hygienic enough. So we need water supply and drainage. We also need fresh air. So for fresh air, we need natural ventilation. But if natural ventilation that is not sufficient, we need to provide mechanical ventilation systems. And ventilation itself cannot achieve thermal comfort because in peak summer seasons, we won't feel comfortable with just natural ventilation. So we have to have air conditioning systems. And we also need lighting. We cannot rely on day lighting. So we need to provide good lighting quality. Therefore, we need lighting installations. And we also need other building amenities like power supply and lift and escalator. Power supply and lift is particularly important. If we do not have power supply, we cannot conduct online teaching like what I'm doing now. Okay, so more specific definitions of sustainable building. That is, sustainable buildings are required to be designed, built, renovated, operated, and revitalized in an ecological and resource efficient manner. Ecological and resource efficient manner, such that they can perform to meet the needs, the needs of different purposes, like our needs or industrial needs, or even pets needs, right? And the main objective, that is reducing the overall adverse impact to the environment through their life cycle. Okay, so buildings normally designed and then we build. After building it, we may need to do some minor renovations, and we need to operate the building to make it occupied and able to be occupied. And then these days we are all talking about revitalization. That means it's like industrial buildings converting into hotel buildings, schools converted into temporary housing, etc. This is what we call revitalizing, much larger scale of renovations. And reducing another objective, that is to reduce the overall adverse impact to the environment throughout their life cycle. Okay. So, more general definitions. Just now, that is more specific. More general definitions for sustainable building. That is, sustainable buildings are buildings that meet the needs of the present. That meets the needs of the present. That means our present generations, without compromising the ability of future generations to meet their own needs. Okay, so on one hand, buildings need to satisfy this current generation's needs, but satisfying our generation's needs at the same time cannot sacrifice the next generations or the future generations in meeting their own needs. So we cannot use the resources of the future generations. We could only use the resources of these generations. And if we use up the resources of these generations, we have to have a way to generate the resources for the future generations. That is a sustainable building. Okay, so this is a very well-known sustainability pyramid. When you talk about sustainability, you need to be aware of this sustainability pyramid that consists of three major issues. That is the environment, economic, and social. Economic, that refers to economic growth. That is mainly that is from the financial point of view. And then we need to also look at the resources. We have to have efficient and maximum use of resources. Efficiency and maximum use of resources, that means we need to optimize the use of resources. That refers to economic. And then environment, we need to know about preservation of natural systems. And also we need to be aware of the carrying capacity of the environment and the pollution problem. So the carrying capacity, later on you'll be introduced. What are the carrying capacity of the environment? And also the pollution problem that associated with the use of resources. And the last one, that is social, that focusing on human needs and on concepts like equity, that means everybody is equal. Empowerment, that is we should have the freedom to do whatever we like, that is empowerment. And then social cohesion, we shouldn't have conflicts between different types, different classes of people. And also we have to have our own, maintain our own cultural identity, that is social. And sustainability or sustainable development, that requires a good balance between economic, environment, and social. About sustainable development, you need to consider whether it is economic, environment, and also social viable. Okay, so you need to consider that three major issues, not just one issue like environment or just economic or just social. So this subject, the focus is on sustainable building development. So you have the building that is affected by the local environment, and then the global environment. And to achieve sustainable building, you need to consider economic, that is main concern, not sacrificing the future needs. And then you have to achieve your social needs and also to maintain good environment protections. If, for example, if you consider short in the environment, this triangular balance between economic, social, and environment will be upset. If it is upset, that means it cannot achieve sustainable development. Okay, so always have that three issues in mind when you need to consider sustainability: economic, social, and environment. Okay, not just one issue. Okay, now why we need to pay so much focus on buildings when we consider sustainable development? Because Hong Kong construction industry has very significant impact on the economy of Hong Kong. First of all, let's look at the contribution to GDP. The contribution to GDP that is not high, but bear in mind that the contribution of building to GDP on its own, that is not high, but we definitely need building to generate GDP, right? Therefore, this 3.54% is already very significant because building on its own is already contributing to 3.4% of the GDP. And their construction cost, that is a very large amount. And let's take a look at employment. That is 2001, 2007, and 2011. Bear in mind that 2011 is not the peak time for construction industry, but the employment rate is already 8.3%, which means almost like 1 out of 10 people is working on the construction industry. That is quite a large employment sector, a very large employment sector. And then we look at number of building stocks in Hong Kong. First of all, we look at residential buildings. And this is from 1980 to year 2000. You could see there is a continuous growth in the numbers of residential units, almost like 58,000 units each year. 58,000 units each year. And then in the 2000 to 2005, we continue to have around 60,000 units each year. But then from 2006 to 2012, there is a significant drop in numbers of residential units. This significant drop that is due to the SARS. Now we have this coronavirus. In 2003, we have SARS. I guess you were very young at the time. You may not aware too much about the threats we're facing because of SARS. And that's why this coronavirus, we take it so serious because during SARS, we have lost in Hong Kong, just in Hong Kong, 299 people died in that SARS. Okay. And then due to the financial crisis in 2007 and also all that, the numbers of residential units dropped and to around 25,000 each year. So you could see originally we have 60,000 and dropped to 25,000. That means each year, if there has been no growth in the numbers of households, each year there's a gap of around 35,000 units. So if you this trend, that is the proper one, which means is the growth should be along this line. And now it is here. Therefore, there's a big gap between supply and if this is the supply, right? Sorry, if this is the demand. So in the old days, supply and demand, they match. If the demand continues to grow like that, but the supply is here, so there would be a big gap between supply and demand. And that makes why the residential properties price so high in Hong Kong. And I'm not here talking about the property price. So I just draw attention that number of residential units, although within the downtime, that is between 2006 and 2012, and even currently, the supply is still in shortage. We still have a stable increase in number of residential units in Hong Kong. And then in terms of commercial floor area, you could see that there has been a stable growth of around 672,000 square meter each year. Okay, in the early years from 1980 to year 2000, and then recent years, that is from 2000 to 2000. From 2000 to 2012, that 12 years, there has been stable growth in the floor area in commercial buildings. So in terms of shortage of supply, commercial buildings is not as worse as residential buildings. But anyway, no matter it is residential buildings or commercial buildings, there has been a stable growth in Hong Kong to see how important buildings on the economic growth of Hong Kong. Okay, any questions? Any questions? Any questions? Okay. Lily, you have questions or you don't have questions? If you have, raise your hand. Okay, so could you please type your questions on the chat so that I could answer you later? It's good that on online teaching I could see all your names. So if you ask questions, I could state your name so that you know I'm answering your questions. Oh, Lily was asking if we need updated information later, and in your seminar presentations and also in future your site visit report, it would be good that you need to present the most updated data. But in terms of examinations, I wouldn't ask you the data, the updated data. And in fact, the numbers of the years in here, that is not as important as you understand that the contributions of construction industry to the economic growth of Hong Kong. That's enough. Okay. Did I answer your question, Neely? If yes, please raise your hand. Oh. Lily was asking where you could find the updated data. The updated data are available in Inland Revenue Department's website. Later on, I will post the updated links to Blackboard so that you could have a look at the building stocks available in Hong Kong. But the data available in the government website, that is not a summary of data. So you need to do some small analysis in order to identify the updated data. Okay? Thank you. Thank you, Lily, for the question. Thank you. Okay, now, sustainable development, we talk about economy, we talk about social, we talk about environment. So here, I give you an introduction of the relationship between buildings and the environment. Now, buildings rely heavily on engineering systems to ensure the design needs that are always achieved. So the engineering systems basically are aiming at achieving our, okay? And engineering systems, they are major resources consumer. They consume energy for the construction, for the operation of the engineering systems. They need water for the construction of buildings. They need water for the occupants that are using the buildings. We need land and materials for the constructions of the building as well as the engineering systems. So nowadays, buildings, they are major resources consumer because they consume resources that are the inputs to the buildings. Input to the buildings. We have inputs. We always have outputs by conservation of mass, by conservation of energy, that sort of concept. So we have input, that is the resources. We definitely, buildings would create environmental loadings, that is the outputs, the outputs. Therefore, according to a lot of studies on sustainable development, that focus was saying that buildings, they are the key target for performance improvement in the interest of sustainable development. So if you want to achieve sustainable development, buildings is the key target, okay? And therefore, in short, buildings and the environment, the major interactions, that is resources consumptions and environmental loadings. So bear in mind that resources consumption, that is input to the buildings, environmental loadings that are output of the buildings. Don't mix up resources consumptions and environmental loadings, okay? Okay? In resources consumptions, when you think about resources consumption, it's always 4 key aspects: energy, water, materials, and land. Okay, so you need to, when people ask you about buildings resources consumption, you think along energy, water, material, and land. There are 4 major aspects. Think along these 4 major aspects. Okay. And environmental loadings. Environmental loadings is always related to pollutions. Pollutions can be air pollutions, water pollutions, noise pollutions, and light pollutions. I guess many of you, when thinking about environmental loadings, pollutions, you would think air, water. Sometimes you would also may think about noise, but light pollutions, that is exclusive for Hong Kong, almost exclusive for Hong Kong. We also think about light pollutions, okay? And then we also consider about wastes generated from buildings, wastewater, domestic waste, construction waste, and also chemical waste that can be from buildings. And also ozone depletions, the materials used by buildings that would generate ozone depletions. And the energy use of buildings normally would end up with global warming, too much CO2 emissions leading to global warming. I would introduce you later in lecture 2 on all these environmental loadings. And also in your seminar presentations, you need to take out more on all these environmental loadings. So the seminar presentations basically focus on resources consumptions and also environmental loadings. Okay? Okay, any questions? Any questions? Okay, and just now I mentioned that building engineering systems consist of active systems and passive systems. If they are properly designed, we give them the name building ecology engineering. Building ecology engineering, okay? And active systems, that is operating to achieve our design needs, that is achieved. That include, as I mentioned earlier, that is power supply, that is power can be electricity. So mainly that is in buildings, power, that is electricity. So electricity supply systems, lighting installations, water supply and drainage, fire protection detection systems, lifts and escalator, air conditioning and mechanical ventilation, and CCTV, communal aerial broadcast distribution systems, broadcasting, and also all these IT networks. So that are active systems provided in buildings to achieve your design needs. Okay, and also we would have passive systems. Passive systems mainly that is building envelope. Building envelope is like helping us to protect us from all these extreme weathers and all that. And building envelopes could be of very different designs. So we would focus on what are the passive systems available in order to achieve building ecology. They together call building ecology engineering. And in fact, no matter it's active systems or passive systems, we need to make sure it's functionable. So we have these operational practices, how to achieve building ecology. And in terms of operational practices, the focus would be commissioning, how we commission the engineering systems, the active systems, and also passive systems. And also we need to conduct post-occupancy evaluation. Post-occupancy evaluations, that means is once the building that have been occupied, how good it is in achieving our design needs, right? And this one would be covered in another subject, that is BSc 1571, Architecture and Built Environment. You will be introduced of operational practices in buildings. So basically, you will be introduced active systems, passive systems, and together with operational practices in BSc 1571. With all this, you could know how to achieve building ecology. Okay. Just now, one student raised a hand. Do you have questions? If you have questions, you are welcome to type in your questions in chat so that I know why you raise your hand. Okay. So throughout the lecture, if you have questions, you could use the chat function to ask questions. Okay, thank you. And now we focus on building ecology engineering systems concerned. Before I move on, let's have a break of around 3 minutes because students may want to have a break or whatever. So let's have a break of 3 minutes. 3 minutes. Hi, welcome back. Why I need to give you a 3 minutes break? Because according to university guideline, they were saying that students wouldn't be able to stay more than 15 minutes. Therefore, we need to give a break every 15 minutes. But I think every 15 minutes, that is a bit too much. So I try to stop every 30 minutes. Hope you don't find this lecture too bored. Okay, so instead of according to the university guideline of every 15 minutes, I stop every 30 minutes. So I guess this is the last 30 minutes on the lecture, and you would have an early finish today. And so building ecology engineering systems, the concerns mainly that is to reduce resources use. If we could reduce resources use, that means if we reduce the input, then the output will automatically be reduced. Okay, so if we could reduce the input, the output would automatically be reduced. And in terms of resources use, as I mentioned, it is always referred to energy, water, materials, and land. Okay, and worldwide focus is mainly on energy use. Okay. So on reduction of energy use or resources use, what did the different nations they have done to mitigate this? What different nations done? In fact, before 1972, different nations they perceive that what we have, the resources that we have, are unlimited. And then, starting from 1972, they start to realize that we would be running out of resources. So they predict that if we continue to consume resources, for example, like gold, it would be finished in 1981, silver and mercury in 1985, and zinc in 1990, so on and so forth. So since 1972, we started to realize that our resources are limited. So they meet on 1980, the first meeting, to see how we could protect the environment. So the United Nations Environment Program was introduced. They have also set up some worldwide for protection of the nature, for protection of the nature. Okay, so that is starting from 1980. 1980, from now, that is only 60 years ago. 60 years ago. And 1985, there was a very important meeting, that is the Montreal Protocol. That is the preliminary agreement that make in a high-level meeting, and they agree to phase out ozone-depleting substances productions and use, and that has already been enforced on January 1989. And related to buildings, that is, they need to. They recognize that we need to reduce the consumption of CFC. CFC that is mostly at the time used as the refrigerant for air conditioning system, and also halons. Halons, that is the chemical used for firefighting. So you see how important buildings on the environment, because for the air conditioning system that we use CFC as well as halon, that basically would lead to ozone depletion. And that Montreal countries and the European Economic Community and ratified, which means is in a meeting they agree something. But once they agree something, they need to sign for agreement. If both actions have been done, then it is called ratified. Okay. So 1985, the very important achievement, that is to phase out the use of CFCs and also all halon products. Okay, so that affects very much on the buildings, because buildings relies on the use of CFCs for air conditioning, relies on the use of halons for firefighting. But anyway, according to that agreement, we need to phase out all these consumptions, and we have replacement products. Okay, and that would be, if you move on to high-level study of this program, you'll see what are replacement products for CFCs, and also what are the replacement products for halons for firefighting. Okay, and then 1987, 1992, that is no major achievements. And then another very important action that has been taken by different nations, that's the Kyoto Protocol. And more than 160 nations met in Kyoto of Japan to discuss measures to reduce greenhouse gas emissions. That's why to a lot of Westerners, Kyoto, that is very famous because of that Kyoto Protocol. If you ask Westerners which cities they know most in Japan, they would say Kyoto. Okay, Tokyo, because Tokyo, that is like the capital city. But other than Tokyo, they all know Kyoto in Japan. And a major achievement in that Kyoto Protocol, that is, they agreed to cut down their greenhouse gas emission by at least 55% relative to their 1990 levels. That is a very, very aggressive target. Based on 1990 levels, each nation need to cut down their consumption by 55%. That is a very, very aggressive target. And the Kyoto protocol that was enforced on February and 2005. And in fact, China, they has ratified the protocol in August 2002. And China has been very supportive to reducing greenhouse gas emissions, so they ratified the protocol. And unfortunately, United States, they signed the protocol agreement in 1998, so immediately after the Kyoto meeting. But then 3 years later, President Bush withdrawn the signature and rejected the protocol. That makes Kyoto agreement becomes less effective. So they conduct additional meetings so as to see how to make, especially the United States, to agree on the protocol. But the United States, they are under the pressure of their citizens, because if you ask them to reduce their emissions, which means is their social needs may be affected. The entire country, they are very reluctant to follow the agreed target for that Kyoto protocol. That is very, very discouraging. And since that, there's no major improvement in the agreements. And then 2015, that is very recent, and they meet again in Paris, and then to start that Paris agreement. So agreement that was reached on the 12th of December 2015. Okay, so they have that Paris agreement. And in that Paris agreement, they try to relax the target. So each country, they are allowed to set their own target based on their national characteristics. Set their own target. And also, one very important agreement that has been made, that Paris agreement, although they have made the target for individual country, but this is not binding. That means if you cannot meet your target, that is okay. Okay, so it's already very relaxed agreement. And the main objective in that Paris agreement, that is because reducing consumptions, that is mainly energy consumptions, that is mainly to slow down global warming. So they have set another target instead. That is what we call performance-based target. That is because our objective, that is to reduce greenhouse gas emissions. Therefore, so as to slow down global warming. So they set the target that is worldwide. The increase in the global average temperature is set as a maximum of 1.5 degrees above pre-industrial level. In the industrial level, that is in the 18th centuries. So not in the 18th centuries. Therefore, they set the target that is already very relaxed. That is only compared to the global average temperature at that time. We try to keep the increase below 1.5 degrees Celsius. And it was very encouraging that the agreement that was open for signature on the 22nd April 2016 and went into effect on the 4th November 2016. Okay, 194 signatories, that means 194 countries they have signed, and 169 eventually ratified, signed, read. And according to that, 169 parties that have been ratified is already accountable for almost 88% of the global carbon emissions. That seems very encouraging. But then United States again, President Donald Trump, they announced that he would withdraw from the agreement. That is mainly due to his election that comes soon. And the last date for Donald Trump to officially withdraw from this agreement, that is by November 2020. So let's see by November 2020 if Donald Trump actually withdrawn from this agreement. But we predict that the United States would withdraw from this agreement. So now, based on 169 parties ratified, including the United States, 88% of global carbon emissions countries would agree to reduce their emissions. But with the news that Donald Trump would like to withdraw from the agreement, and this percentage was significantly dropped to around 60+%, because the United States, that is a major carbon emission country. Okay. And then when you look at Kyoto status, those white in color, that is, we don't have any information. Here, that is the Greenland. Greenland belongs to Denmark. And you could see here that the United States and Australia, for that Kyoto agreement, they signed only, they didn't ratify, which means they don't agree to take action to reduce emissions. Okay, so Australia at that time, and also the United States. And then the latest information on this Paris Agreement, you could see only Russia and also small numbers of countries in Africa. They do not agree to the reduction agreement. But then you would expect later we would have the United States that may possibly be withdrawn from this agreement. Then this is 2015, and then by 2020, if the United States eventually withdrawn, then you would expect by 2021 or 22 would be another major meetings to convince the United States to join the agreement. So after this lecture, pay more attention to the global agreement on the emission targets, okay? And then Hong Kong is a special administrative region of China. And China, they have ratified both the Kyoto Agreement and also the Paris Agreement, which means Hong Kong, they need to do something to cope with the agreement made by the mainland government. So let's take a look at what did the government they have done. Okay, so the agreement that they have done include Hong Kong government, like a lot of research studies saying that if you want to achieve sustainable development, if you want to cut resources consumptions, the focus are on the buildings. So Hong Kong government also introduced many measures to achieve sustainable building development. And we try to classify the initiatives made by the government according to passive systems, active building systems, and also operation practices. Now, for passive systems, the government look at the urban design and also the building envelope. The government introduced measures to govern the urban design and building envelope. In urban design, the government introduced this air ventilation assessment. I guess you all have heard of buildings in Hong Kong that is well known for high rise and very high density, high rise and high density. And some are what we call like wall buildings, so that it would block the flow of air within a housing estate. So the government requires all building developments before they are constructed or they start the constructions, they have to do air ventilation assessment so as to enable buildings, they are not blocking each other in terms of air ventilation. That is one measure introduced by the government. And another one, that is what we call OTTV code. OTTV code, that is when the building that's been designed, they need to, the envelope design has to be of a certain standard. That is to enable the building envelope that is a good envelope so as to isolate the indoor from the influence of outdoor weather conditions. That is the OTTV code. And then in terms of active systems, the government introduced these building energy codes to govern the energy usage of air conditioning systems, electrical systems, lift and escalator systems, and also lighting installations to govern the design of all these installations so as to minimize the energy use of the building engineering systems. This is for new buildings. For existing buildings, they require all existing buildings to conduct what we call energy audit. Energy audit, that is to enable building engineering systems after being used, they are still in good conditions. And then in terms of operational practices, the government focus on controlling the facility management, that is managing the facilities inside building. Facilities inside building, mainly that is the envelope, that is the passive systems, and also the active systems. And they have what we call the carbon audit guidelines to audit, to check the carbon emission levels for both the building envelope, for the engineering systems, and also daily operations of buildings. And they require also buildings to conduct life cycle cost analysis. They require buildings to conduct post-occupancy evaluations after being occupied, how good it is in achieving the needs of the occupants. They require indoor air quality certifications. If you we in block set, right? If you go into the lift in block set, you would always see that this building air quality that is good class or very good class or excellent class, that is required by the government, that is indoor air quality certifications. And buildings being used for a certain period of time, the government also required them to do retro commissioning. And in terms of controlling both passive, active, and operational practices, the government also introduced one assessment requirement, that is BEAM plus assessment. BEAM, that is Building Environmental Performance Assessment Method. So they require buildings in good conditions, both passive, active, and operational practices. That is BEAM assessment covers all three areas. And the government also required all buildings to introduce BIM modeling, that is Building Information Management Modeling. This is now is very highly pushed by the government so as to enable all information about passive system, active systems, as well as operational practices to go digital, so they could easily evaluate the purpose of these three systems as well as to make changes on the different systems. That is BIM modeling. Now, for majority of you, seeing like air ventilation assessment, OTTV, building energy codes, so on and so forth, you may find it too not familiar at all. But don't worry, because the syllabus design, or no, the program design of this building services engineering program, that is like there will be vertical and horizontal integrations. That means is in level 1, you may be introduced of different discrete information about buildings, and then based on level 1's general knowledge, you then continue to build up. So like OTTV code that would be introduced in architecture and built environment, that is BSE 1571. You would also be introduced of post-occupancy evaluations and also life cycle costing analysis, carbon audit in your level 1 subjects. And then when you move on to upper levels, you will be introduced of like virtual commissioning, and also building energy codes, energy audit codes, and more important, air ventilation assessment and beam assessment, BIM modeling. That would be introduced in the higher levels of subjects in the program. Okay, so that basically completes today's introduction lecture. And for by all means, if you have questions, you are welcome to email me. And if you want to see me, you could always welcome to come to my office on your own. And I'm in my office most of the time. And all these teaching materials have been uploaded to Blackboard because of the coronavirus situations. The teaching scheme may change from time to time. So if you look at the information that I've uploaded to Blackboard, you could see teaching scheme, that is version 1, version 2, right? Revision 1, revision 2, so on and so forth. And there may be more revisions, and I hope you would excuse me for making changes so frequent, because a lot of things that are out of my control. Okay, and then do you have further questions on the lecture? If yes, please raise a hand so that I could answer you before I finish the lecture. Okay, yes, Lily, you have a question, please ask. Yes, for other students, if you have questions, please raise in the chat room so that I could answer you before finishing the lecture. So raise your hand and please check so that I know your questions. Oh yes, very good questions, Medina. The lecture has been recorded, so I would later upload it the lecture that has been recorded to Blackboard, so that you could watch again. Bear in mind that you have to use Chrome or Firefox or Edge platform. IE platform doesn't work. Okay, so I would upload the lecture to Blackboard. Any other question? Oh, Lily was asking how the site visit will be held later. I target to have it after the recess period. So after the recess period, we would arrange a site visit, and your class would be split into 2 groups. So it would be conducted within the lecture hours in 2 separate groups, and we would have subject lecturers guiding you on the key installations in the site visit. And after this site visit, you need to conduct another self-arranged site visit with your classmates. And ideally, the site visits will be conducted after the recess period and after the coronavirus problem that has been over. If unfortunately by then the situation is still worse, then we would redesign the site visit requirements so as to enable all students are comfortably able to complete the assignments. Okay, so the site visit, if possible, we would try to arrange after the recess period. If the situation doesn't allow, we would consider alternative arrangements, and I would announce to all of you later. Okay. You also asked about in-class test. In-class test that has been assigned to be conducted by end of the semester. If by end of the semester the situation is still worse, like in the first semester, we will conduct online assessment. So as long as the situation has become better, then according to university's instructions, we would consider whether the lectures as well as the visits and also the in-class assessment would be conducted in class or would be conducted online. You would definitely be informed well in advance. Okay? Any other questions? Any other questions? Sorry, just now someone knocking on my door. I don't know if they have created some nuisance to you attending the lectures. If yes, please accept my apology. Please accept my apology. And I always look forward to see all of you, to be honest. And seeing you like that or not able to see you like that, I also don't feel comfortable. But anyway, if you want to see me, you're welcome to come to my office. You're most welcome to come to my office. I love to see you all. To be honest, I want to see all my students. Thank you. Any other questions? Okay. If not, then I would say bye-bye here and close this lecture. And I would later post the video to a video link to Blackboard so that you could revisit and also watch this video in order to follow easier the lecture. Okay. Now, no more questions. Then I would say bye-bye. Thank you so much. See you next week, 8:30. 8:30. Okay. Thank you. Bye-bye.